Imagine that you are creating a game and you are working with some assets, such as textures, sounds, models, and so on. You have an assets manager that helps you easily retrieve and work with these assets. Right now, you instantiate and use the manager's instance in every game scene, and even in every game script. And because of this, the resources are loading every time. You realize that if you already load some resource, then most likely you want to use it again in the near future, so there might be a good reason to cache those assets for future use. But in our current code, creating the manager every time is a problem, because the resources are not cached and we can't reuse them. This is where the Singleton Design Patterns comes in handy, and can help us create a manager just once and take advantage of caching everywhere. Now, let's talk about Singleton itself. The Singleton Design Pattern is a creational design pattern that ensures a class has only one instance and provides a global access point to itself. Singleton ensures that a single instance of a class is created and shared throughout the life of an application, which prevents multiple instances from being unintentionally created. Let's create an Assets Manager class that will be the main actor of the Singleton Design Pattern. It should not have any public constructors to create itself, only the static method named getInstance should do it. The user should call this method to receive an Assets Manager instance, and after that, they can use any non-static method with it. The user will not know anything about caching or internal optimizations, because this logic will be encapsulated in the Assets Manager class. There is only one actor in this design pattern, the singleton itself, which is a class that implements the singleton pattern, ensuring that only one instance of it can exist. The Singleton Design Pattern offers several advantages. One of the key benefits of the singleton pattern is providing a single, well-defined access point to an instance, ensuring global access and making it easy to manage and use throughout the application. This design pattern also excels in resource management, as it can control the allocation and release of resources, guaranteeing their efficient use. Furthermore, a singleton is capable of maintaining a unique state within an application, which is particularly useful for storing configuration settings or shared data that need to be accessed by various components. Additionally, the singleton pattern can support lazy initialization, meaning that the resources can be loaded on demand. This improves performance by deferring the load of the resources until it is needed. Despite its benefits, the singleton pattern also has its drawbacks. Testing can become a challenging task due to tight coupling and global nature of a singleton, making the codebase difficult to test. In multi-threaded environments, there is an added complexity, as the creation of a singleton must be thread-safe to prevent race conditions, ensuring that the instance is created only once, even when multiple threads attempt to create it simultaneously. In general, singleton is mostly seen as an anti-pattern because it adds complexity to the code and is very difficult to reuse or test. Eliminating singletons can be a challenging task, but it is an effort that pays off in the long run. That's all about Singleton Design Pattern. See you in the next video.